Okay, so today we will be discussing on the type of valves that we have and which are locations we are going to install as a chill water system. Okay, so if you remember in classification of air conditioners, we had discussion on chillers. You guys remember? Anyone of you please respond. Did you guys remember we had a discussion on chillers altogether?
Yes, sir.
There's something called as
But
air-cooled chillers and water-cooled chillers as well. So
yes,
in chillers, what are we doing? We use primary refrigerant to cool secondary refrigerant like water, and it clearly told we will pump water to AHUs, right? So when we pump this cold water to AHUs, we require certain valves for getting the total functionality, either to clear the debris or probably to control the refrigerant also. We require certain elements. So, or certain valves. So those valves is what we are going to discuss today. Okay? Fine. So what are the valves that we have? So first and foremost thing is ball valve. So these ball valves are basically used for isolation purposes. That means you wanted to say, for example, you have something called as a fan coil unit. Okay. So fan coil unit is like a AHU only, like it will have a coil, but only thing is the coil size will be smaller and the static pressure of the fan will be lesser. That means you wanted to throw to a very small distances, you will use that particular fan coil unit. It is also like a ductable split AC, for example, but of a lower capacity, you imagine. But instead of directly connected to compressor, you will be pumping cold water into it. Understood? So that kind of equipment is called as a fan coil unit. Okay. So, or anywhere where you want certain isolation to be done. At those all locations, we'll go for this hardware, which is called as ball valve. This ball valve is available right from 15 for us. So 15 25 20 25 32 40, 50 also is available, but generally up to 32 we use this ball valve for our HVC applications. Clear? Up to 32 pipe dia, we'll go for this ball valve. So this ball valve is just an on and off functionality, nothing else. Clear? And generally we go for PN16 rating. That means it has to withstand up to at least 16 kgs per centimeter square. That's a general rating that we always consider. So that, I mean, of course, it depends on your pump head. But anyway, in most of the applications, it will not cross 16 kgs anyway. Understood? Am I clear? So this particular valve is called as a ball valve. And locations where do we use it is outlet of your fan coil units, you will use it. At every pressure gauge, you will use it. At drain point, you will use it. At multiple locations, you will use this ball valve. Here, then coming to the next one is our ball valve witch trainer. So this ball valve witch trainer is a hardware used for isolation as well as to it's like a filter. It's like a debris cleaner for us. So this hardware we use it at inlet of your fan coil unit because inside your coil you have multiple turns. That means I'll just explain you in a plain CAD drawing. Let's say this is our fan coil unit. So generally, inside the fan coil unit, as I've told you, you will have like I'll just explain you the basic structure of a fan coil unit or a ceiling suspended AHU. So backside of the same like your ductable split AC, you have a filter. You have a filter, and then you will have a coil, or you can have a blower fan. Depends on the draw through type or whatever it is. Let's say I've got a fan. So this is your blower fan. Let's say. which is pushing the air forward. Ready? Let's say this is your blower fan, which is blowing air from backside to the front. In the front, you'll have a coil. Okay, you have a coil. So this is the cut section I'm making. Okay, but technically, if you ask me, all these coils will be connected to each other. It's a single copper pipe which is bent. Understood? Am I clear? So let's say this is your inlet piping. Sorry, excuse me. This is, let's say, your inlet piping. And the top will be your outlet piping here. This is your outlet piping. Let's see. Okay, so now if any debris or anything, if it enters into the coil, do you think it's easy? Do you think it is easy to clean this coil? Because this has got a lot of turns.
No.
So if there is any particle or anything that enters into it, do you think it's easy for us to clean?
No.
It's tough, right? So for that reason, what we do is we always install a filter at the entry point. So when the dia is small, instead of using something called as like, a separate strainer, we'll go for a ball valve with strainer. So at the exit point, you'll just go for ball valve. At the inlet point, you will go with ball valve with strainer. Understood or not? Am I clear?
Yes.
Okay. So this particular hardware, we will use this ball valve with strainer at the inlet. We'll use this ball valve with strainer at the inlet of the coil. At the outlet, you will just go for a simple ball valve. Clear? So, how do you operate is basically like, of course, whenever there is a water, basically we provide a drain point also. We'll close this handle. The minute we close this handle, this could be removed. So once this could be removed, there'll be a strainer inside it. There'll be like a kind of a basket. So that basket, I mean, whatever gets entrapped in it, it will get entrapped into that particular basket. That basket, if you remove it and clean it, it will be done. That's it. I mean, anyone can clean this. This particular is called as ball valve, this strainer. Then you have something called as butterfly valve. Okay. Like this, you have it, or most of the times we have it with a handle. Okay. I mean, I'll just show you one more type of butterfly valve, which we generally have it. Butterfly valve. So like this, we generally use it. Either that or this. These is the types that we generally use it. Understood? I'll share you this PPT also. Don't worry. Oh, sorry. I guess it got pasted in a wrong this thing. So you have butterfly valve even like this as well. And most of the cases, 90% of the cases, we use these types only. So you'll have a lever with a handle. You will just press it and then you rotate it. So when you rotate it, the discs open something like this. Understood? So this one you call it as a butterfly valve. The name is simple because the in between whatever you have it works. It seems like a butterfly. That's the reason. And you have like butterfly opening models also are available, but generally we have these rotary ones. Understood? So the butterfly valves, whatever you have it, these butterfly valves, always remember, these butterfly valves is also used for isolation, especially if the pipe diameter is bigger. That means about 32 mm. Like for example, like AHUs, chillers, pumps, at all the locations, inlet and outlets, wherever you want some isolation work to be done, there you will use this butterfly valves. Understood? Hello?
Yes.
So that we use butterfly valves at inlet and outlet of AHUs, pumps, and chillers. Then coming to the next one that we have is this is also same like a ball valve, but only thing is this is used for bigger diameters. Then coming to the balancing valve. Balancing valve is basically a hardware which is used to balance the balance the amount of water. I'll just explain you a logic. I'll just make a simple circuit so that anyway we will use that circuit. So let's say I've got my chiller. Okay. So I've got my chiller, let's say. So from the chiller, let's say I've got like three chillers out of that two working, one standby, let's say. Okay. So then what we'll do, we'll basically have a piping system from the chiller. Let's say it's air-cooled chillers. So only one side I'll have a circuit. Let's say this is my system. From the chiller, we'll have water that will be collected from the chiller, and from the chiller, basically, we will be collecting the water, and then we will be circulating it to multiple AHUs. Yes or no? So let's say I've got three pumps as well. Generally, in a circuit, what do we do is how many number of chillers are there? That many number of pumps also we'll always place. Understood? So this is one pump. This is second pump, and this is third pump. Let's say. Should do it. So this is the pumping system that we have. Done. So this is our pumps that we have it. All the valves and all also I'll show you in this circuit only, don't worry. Okay. So this is our pumps circuit. And from the pumps, basically, I'll be connecting it to multiple air handling units, right? So for that reason, I'll just, shall I draw AHU also like block itself? Are you guys okay with that? This is AHU1. Let's say AHU2, AHU3, AHU. I'll generally have multiple AHUs anyway. So this is a AHU. 2, 3, 4. These are our AHUs. This is AHU1, AHU01, AHU02, AHU03. Let's say this particular guy is a FCU or this particular one, let's say is FCU. 0.3. So this is, let's say, is FCU, smaller capacitor. I'm just showing with the smaller this one. So this is an FCU, and then we have got AHU03. So let's say these are the four AHUs I've got it here. Practically, you have a lot more, but anyway. So all this piping will be connected from the chiller to AHU. You agree? And from the AHU, again, we will collect back the piping. From the AHU, we will collect back our piping. It should increase in that. This is going back to chillers, let's say. Okay. This is going back to chiller. If the circuit is small, you will use a single set of pumps, else you will use two sets of pumps. Understand? So this is AHU to chillers, and then this is chillers to AHUs. Clear? So whenever you have a circuit, basically chillers to AHU to chillers, whatever you use it, that particular circuit you basically call it as a primary pump. This particular circuit you call it as secondary pump. I'll write text as well. So AHO to chillers, we'll basically call it as like this one. This is chillers to AHO, right? This is called as secondary pumps. Secondary pumps. It's not mandatory that we should have secondary pumps. If the circuit is small, we'll just use primary pump. I'll explain you about all those things either today in the next class or next class. So these are our secondary pumps. And then we use the next one, which is our primary pumps. These are our primary pumps. Yeah. These are primary pumps. We have got it. Yeah. This is the circuit. So this is the total circuit. Understood or not? If it is if it is air cooled chiller, water cooled chiller means from here again you will have one more circuit to the cooling tower, and from the cooling tower you'll have a condenser water pumps, and from the pumps again it will come back to chiller. But for now, let us assume it's air cooled chiller. So condenser is cooled using air only. Like your evaporator side, you will bring some water. Am I clear or not? Are you sure?
Yes.
Now, if we wanted to place the valves, so so I'll write the text here. Let's say this is our ball valve. Let's say this is a ball. I'll write the symbols also. I'll do one thing. I'll make colors so that you'll understand return and supply. So here this circuit is like this. So this is supply, and this bottom is return. Let's say. Yeah. So this is our return path. I wanted to make it with the red color. It's comparatively hot, alva. Okay. It's cool. I'll just make all these lines into red color. This is sorry. This is your return, and this is your supply. Supply to the chillers. Yes, this blue seems better. Yeah. Is this visible? CN is visible? Oh. So from the chillers, the cold water is entering into AHUs, and from the AHUs, the return water, whatever comparatively hotter water will be going back to chillers. You agree? That's the final circuit, right? So in this, we will always place our butterfly valves at inlet and outlet of the AHUs or the ball valves for isolation purposes. We already had a discussion. But the next hardware is balancing valve that we're going to have a discussion on. Now, without any balancing valve, if I just have a butterfly valve, can you give me a guarantee that desired water could be flowed into AHU as per its tonnage?
No.
So we should have some mechanism to regulate the resistance or the friction so that the fluid will flow as per the desired quantity at every location or not? Because according to the capacity only the water will be flowing. You agree? So for that reason, we have something called as balancing valve. We have something called as balancing valve. Nowadays, you have something called as a PACV. That is a separate one which I'll be explaining you, don't worry. So you have something called as a balancing valve, which we use it always at all the AHUs. So we will use a balancing valve at AHUs outlet, never at the inlet you will install it. Okay, you will install it the FCU coil also. You can have a kind of a balancing valve. You will have a balancing valve, and then at chiller's outlet again you will have your balancing valve. What is your chiller outlet? Chiller outlet is this thing. You agree? At all these locations, you'll have your balancing valve. So what does this balancing valve do? Inside the balancing valve, if you see, there is a kind of a V section. So because of this particular, when you push this, when you rotate this handle, this pipe, this spool, whatever is there, that will lift upwards. So this lifts upwards or downwards. I mean, it depends on your orientation, clockwise or anti-clockwise. Yeah. So when you do this activity, automatically this V section, I mean, fluid will flow through this V section. Understand? So because of that, there will be certain resistance that will be caused, or it will be free flow, any of the things. So when that particular thing happens, automatically the fluid will flow, or it will resist to a certain extent. So when you add resistance, so what will happen? For example, if this circuit is there, don't you think your AHU1 is very near to your pumps compared to AHU4? Hello, I'm audible.
Yes.
Okay. So don't you think your AHU1 is very near to your pumps compared to AHU4, or everything is equal?
It's more.
It's near,
One
right?
is
So
near.
what should we do? AHU1 valve, we have to close it partially or to larger extent compared to AHU4, so that your AHU1, whatever amount of flow is required amount of flow is there, the same amount of flow you want it in AHU4 also means. What should you do? You have to balance the particular valve. Only then the desired water flow will happen. You agree? Similarly, chillers also, chiller 1, 2, 3, let's say, the first chiller is near to your pumps, third chiller is far. So what will we do? We have to do the balancing activity. Am I clear? Understood
Yes,
or
sir.
not? So
Yes.
this is nothing but your the same, which is your that is what we have to do, which we call it as a balancing activity. Yeah. So for that we use this balancing valve. Now, we always install it at the outlet of the devices in the air. Like, if this is the flow, let's say, just a second, I'll make an arrow mark anyway. This is the water flow direction. Alva. So this is the arrow mark, let's say. So this is the water flow that we have it. So this is the orientation. So this is your water flow direction. So this is the direction. Okay? So from here also, the water will be flowing in this direction. The counter presence anyway there. Okay. So this is the total circuit. You agree? So now at the outlet of the devices only, it's mandatory for you to install the balancing valve, not at the inlet. Logically, yes, you can ask me, why can't you do it at the inlet as well? Inlet or outlet at the same resistance that you're creating in a circuit, that's it. But if you do it at the inlet, the turbulence will go into coil, which can affect the heat transfer rates. Understood? Because inside this you'll have a coil alwa. So if you install at the inlet, what will happen? There will be turbulence that will be caused. So that turbulence, whatever happens inside the coil, if it goes, you can't guarantee proper heat exchange. For that reason, we always install it at the outlets. Am I clear? Understood. So these are locations we'll install our balancing valve at the AHU and chiller outlets. You will install your balancing valve. If you have a cooling tower outlet also you'll install. For that, the inlet you will do it actually. But anyway, so that is nothing but your balancing valve. Am I clear? Because inside the cooling tower you'll not have a coil. That's the reason. Clear?
Yeah.
Then coming to the next hardware that we have is after this one. The next important hardware is after balancing valve. We have something called as a gate valve. This also is used for isolation, but the pressure is very high. 99.99%, unless the project is very huge, like entire airport you're trying to do or anywhere, you don't use this gate valves. In firefighting, yes, we'll use it, but in in this one, we generally try not to use this particular one. Yeah, this is also used for isolation purposes. Then coming to vice strainer. So this vice strainer is a hardware which is used to clear the debris inside the pipe circuit. So this vice strainer, we use it at the following locations. We always use the vice strainers at the inlet of AHU. This vice strainer, you'll always insert it at the yeah. So this is a vice strainer. So we always install this vice strainer at the inlet of your AHUs. The main reason why we use this vice strainer is you want to make sure that you wanted to clean your water. Understood? You wanted to clean the water. So for that reason, you always insert it at the inlet of your AHS units. Fan coil inlet, what did you use? Inlet of fan coil, what did we use? This respond.
Valve with strainer.
Ball valve with strainer. Right? So at fan coil unit, you will use ball valve with strainer. Normal strainer, you will use it when the dia is greater than 32, in which case we will go for strainer at the inlet of AHUs, and we will install the strainer even at the inlet of your pumps as well. Every pump inlet, it's mandatory for you to install your this vice strainer. Understood? So, so you will install your vice strainer at the inlet of your pumps. We'll install the strainer at the inlet of your pumps. At all these locations you will install, but we do not require it be chillers unless, of course, we can install if you want. But pumps and chillers are generally 99%, it's all near to each other. So if something gets stuck here, you will clean it. And again, at this location, you don't require it. If the plant room is very huge or where you want very critical or you wanted to save your chiller means, if you're interested, you can place it even at the chiller inlets also, but it's not a mandatory. Understood? So these are the locations you will install your vice strainers. At the AHUs inlet and pump inlets, you will install your vice strainers. Clear? Understood or not?
Understood.
Then coming to the next one is pot strainers. Pot strainer, we use it for open circuit, especially when you have your cooling towers. When the circuit is big for smaller projects, we use that also by strain, not a problem. But if the project is big where there's always a lot of debris collection, then we'll go for something called as a pot strainer, which will be installed in the inlet of condenser water pumps. That is nothing but your your when you use your water cooled chillers, then we'll go for the pot strainers. Yeah. So this pot strainers will be used. Say, for example, if you have a circuit of, I'll just draw one more circuit. Okay, please don't mind. I'll draw one more circuit for these, let's say. So this circuit is, let's say, is your cooling tower circuit, if we have it. So this circuit will basically use it as, let's say this, I'm using other color like pink or something. This is, let's say this is water cooled chiller now. So this is a water cooled chiller. Don't you think I should have even a circuit even for my cooling tower or not? Yes or no? So let's say I have got a circuit for my cooling tower. From the cooling tower, let's say this is our circuit that we have it. So from this circuit, let's say I have connected to my cooling tower. So from this, the water is getting collected and then we are shifting it to cooling tower. Generally, cooling tower will always be placed above the chillers. I'll explain you why later. So this is our cooling tower, let's say. Again, I'll have a cooling tower. So, yeah, so my cooling tower. This is cooling tower one. Generally, how many numbers are chillers are there? That many cooling towers also you'll use it always. Okay. So, 0.6. So let's say this is a cooling tower one. Now multiple cooling towers across the circuit, let's say. Okay. So this is cooling tower two, cooling tower three. These are the three towers I have it. Okay. So from this, the water is going to your cooling tower. So from the cooling tower, water will again come back. So check. And let's say this is our cooling tower circuit that we have it. Yeah. So from here, again, I have one more pump circuit. So how many number of cooling towers are there? That many number of pumps also will be available always. Okay. So let's take this is from the cooling tower to chiller. So the direction will be something. Right. So, but I'll not have by strainer. Instead, I'll have our resistance. This I'll write it as condenser water pumps. This we call it as condenser water pumps. These are the condenser pumps. So these condenser pumps will be connected to the cooling tower portion and make it comparatively colder. So I'll use some green color. It's okay. So these are the cooling tower water, which will be pumped back to your chillers. Am I clear? This will be connected to your chillers. Just a sec. Yes, something like this. Yeah. This will be connected to your chillers. So again, it will be connected on this side of the chillers, let's say. So I'll do a small exercise. So, yeah, I think it's a interesting type. Let's see. Green color circuit and green color. Set. Done. So let's done. So this is the circuit. Okay, here's my circuit. That thing I've got. Understood or not? So this is again our water flow direction. Just a section. Okay. Okay, done. This is also circuit, and this is again. This is the direction of our arrow. Okay, and this is the supply from the cooling tower. Sorry, from the chillers to cooling tower. Always remember, after the cooling tower only, you'll have your pumps. Understood? So this is condenser water. So this is your chillers, and from the other chillers, obviously we'll have two circuit breaks if it's a water cooled chiller. So one is towards the evaporator side, and other is your condenser side. You agree? Hello.
Yes, sir. Yes, sir.
Yeah. So now this particular one, at this condenser water pumps, we will install our strainers. So we have used the Y strainers at your this one, but whereas in this location, you can use a pot strainer. So one option is you can have a single pot strainer and you will keep it with a bypass line, or you can have two pot strainers. So it's up to you, or three pot strainers as well. That you call it.
So that red color line is primary pump
Which one?
for this one. Primary
The
pump.
red one, AHU2 chiller. Sorry. Yeah, this is primary pump. It's my mistake. Yes, I didn't correct it. The red color one is primary pump. The AHU2 chillers is your primary pump. Yes. I didn't edit the text, I copied it from where it it. Anyway. Yeah, so this one you have it. So at these locations, the inlet of your condenser pumps, you can go for your pot strainers. Understand? You can have your pot strainers in these locations. Am I clear?
Yes, sir.
So this pot strainer, advantage that this pot strainer, just a second. Advantage of the spot strainer is the spot strainer can withhold more debris. Understood? The spot strainer will be able to withstand more debris. For that reason, you will install the spot strainer at the inlet of your pumps, where there's always a chance of, because in cooling tower, don't you think the water is open? That means it is connected to atmospheric air or not to cool
Yes,
whenever
atmosphere.
public. So that can have a lot of debris, right? You can have a lot of salt crystals, or you have got a lot of acidic nature, and you have a lot of hair particles, like a lot of dust can accumulate. So for that reason, we go for this kind of hardware, which is called as your pot strainer at the inlet of your condenser water pumps. Am I clear?
Yeah, yes, sir.
So these are the pot strainers we have in this machine. Then coming to the next one that we have is three-way modulating valve. So nowadays we don't use this three-way modulating valve. You'll generally go for only two-way modulating valve, or even nowadays we have PACV valve, pressure independent control valves. Okay. So this three-way modulating valve, if you see, don't you think you can see three openings? One, two, and three. Yes or no? Don't think you can see three openings for this modulating valve? One, two,
Yes.
and three. So these
Yes.
three will be used basically to modulate the water. Let's go to the second case where I've just used only primary, that is also without any VFD. That means we call it as constant flow systems. So you don't have any secondary pumps at all. If the circuit is small, directly you have pumps from the AHU to chillers, and this chill from the chillers directly the water will go to AHU. Understood? So in this kind of circuits, you don't have secondary pumps concept on it. You will just have primary pumps that also will run with full speed. You don't have any variation of fluid flow. Understood or not? So that type of circuit you call it as constant speed circuit. You call it as constant speeds or constant primary pumps type. That circuit you call it as constant uh, primary speed type circuit. Yeah. So this type of hardware you use it in this type of circuit is like, in olden days we used to use this. Nowadays we always use this VFD, so we are not even using three-way multiplexing. But anyway, as it's existing in the market and just explaining it. That's it. So in this case, what is happening from the chiller, like your refrigerant is going to your AHU, and from the AHU it is going back again to your chiller. You agree? So now, in this case, you don't have any VFD or anything, but inside this AHU, you will have your coil or not? Inside every AHU,
Yes.
right? So this coil, if you continuously pump cold water, irrespective whether that room has received a temperature or not, if you continuously heat exchange it, then don't you think you will have an issue of subcooling the room? That means you want 25 degrees centigrade, but instead of 25 degrees, don't you think you might maintain 20 degrees? Yes or no?
Yes.
So for that reason, we use this hardware, which is called as two-way modulating valve, where it regulates the amount of water that is being pumped into the system using the thermostat. Yeah. So you have a hardware called as three-way modulating valve, where it has got 3 points. If you could see, there were three circuits. Generally, one will be inlet, one will be outlet, and other will be bypass line. So what we'll do is this modulating valve of whatever we have it. So this is motorized valve. This is a motorized valve. I'll just show you this again. This is a motorized actuator. This we call it as actuator. Understand? So in which it will be able to rotate the spindle. So here this valve works in one principle. So one is inlet, one is outlet, and other is basically a bypass line. Let's say this is your in point. This circuit is in. This is in. Let's say this is out. And this is bypass. Bypass point. So this is your bypass line. This is your in, this is out. So this hardware we call it as three-way modulating valve. So this three-way modulating valve works on a simple principle where we install this three-way modulating valve at the outlet of your AHU. So here what we do is basically we use this particular hardware at the outlet of your AHU. Here, the outlet only, no? It's always modulating valve also it was just installed at the outlet of your AHU. But how will you connect is a question. Just a second. Inlet, outlet, and the bypass line, right? So just a second. I'll make it parallel to this way, just to understand it. Okay. The circuit will be installed at the outlet. So from here, let's say you will basically connect your bypass line in this fashion. So your main line should be connected this way. Basically, this will bypass the circuit. That's it. Or I'll change the connections. I guess. I'll try to explain. 6 yeah. So here it will connect. You will install it at the this location. But generally, what do we do is this circuit will be connected. This bypass line will be connected from here to here. I mean, you will do a connection between these two. You will create one more piping circuit like this. Understood or not? Am I clear? So this is your inlet, this is your outlet, this is your inlet, this is your outlet, this is your bypass line. So now what will happen is this will be connected to your room thermostat or your temperature setting that you wanted to keep it inside your room. Okay. So this particular one will be connected to temperature sensor. Just mark it, let's say. So this will connect it to a temperature sensor. This we call it as thermostat. the silver connected thermostat. So the logic will be made in such a way that whenever the temperature is reaching, let's say you wanted to maintain a room temperature of 23 degrees centigrade. Okay. If you wanted to maintain a room temperature of 23 degrees centigrade, plus or minus 1 degree, let's say I've kept it. So at 22 degrees centigrade, it should not allow any water that is entering into your H coil. Understood? But if the temperature is lesser than 22, it should partially open. If the temperature is somewhere around 24, it should open 100%. You agree? If I pump cold water into coil, because AHU fan you're not controlling, AHU fan continuously it's running. But now let's say you wanted to control the temperature. So what parameter I can control? The amount of cold water that is being sent into AHU or not?
Sensor.
So for that reason, what we do is we'll place this at the outlet, and what it does is, let's say the temperature, I'll just give an example. Let's say the room temperature currently is uh, room temperature. I'll write two parameters. One is room temperature. I'll write it as say 23 degrees centigrade. And currently the temperature of the set point, I'll write it as set point, let's say is let's say set point is 23, currently the room temperature is 25 degrees centigrade. Set point temperature is what we are looking for. Understood? I mean, what is the customer want? I want 22 degrees. You set it in remote alva. That particular one we call it as set point. Understood? But currently the room temperature is 25. So if the room temperature is 25, but I want 23. Now you tell me, do I have to send cold water into it, or I have to close? I should stop sending cold water into it. Hello. Please respond.
Can you repeat it?
As your question, let's say inside the room, okay, I'll draw coil and everything. Let's say this is your AHU. Inside the AHU, you've got coil, right?
Yeah.
The fan we are not controlling at all. But if I wanted to send the room temperature, so in this coil, we are pumping cold water from your chillers. Only then it will heat exchange from the room space. You agree? Okay. Now the room temperature is 25 degrees centigrade. Currently, that means currently the room is having a temperature of 25 degrees centigrade. But I want as a customer or occupant, I wanted to have a temperature of 23 degrees centigrade. So should I still send cold water, or I have to stop cold water? So what is my target? To maintain my room temperature equal to set point temperature. Do you
Set
agree?
point. Yes. Yes.
Yes. Now you tell me, do you have to send cold water, or I have to stop sending the cold water?
Have
I didn't get you, sorry.
have to send it because
I have to
is
send
static.
cold water. Right, right. Obviously. So we have to send cold water to this space. Then what will you do? This will create a channel just between inlet and outlet. It will create a channel between just inlet and outlet. It will not connect it anything to bypass. Bypass will be closed. So, somehow this. So it will create a channel like this. So if it creates a channel and bypass is completely closed, so this part is closed. So will there any water that bypasses the coil? If this part is closed, let's say here I've closed it entirely. Wait, let's say, let's say this location I've closed it. I don't have any water connection that is entering into this coil through this bypass line. If you tell me, if it is closed entirely, can any water bypass the coil if this part is closed?
No.
So don't you think 100% water is entered into through your coil only?
Yes.
So for that reason, this particular one will be in open state. But let's say, so after some time, the temperature slowly reduced. But now it's reversed. For example, set point is 23, room temperature is 21 degrees centigrade or 22 degrees centigrade. Now, do I have to send any cold water?
No.
No, obviously, because it will be super cold, sub cold. But if I want 23, already the room temperature is 1 degree lesser. So then what will you do? It will close like this and it will create a channel like this. It will create a channel like this. So water will be, you will have a opening something like this, but whereas inlet will be closed 100%. If inlet is closed here in this circuit, will there be any water that will enter through the AHU?
No.
100% water will be bypassed through this line and then it will come out. You agree?
Yes.
So like that, we regulate the water temp. At the same time, you can have even 50% also. Let's say the room temperature is 23 and this is also the 23. Then what will happen? 50% it will take from inlet, 50% it will take through bypass. So like that, by regulating the amount of refrigerant, we are basically controlling the water. Understood or not? By controlling this water, don't you think you can regulate the room temperature or not?
Yes, we can.
Right? So that's what we do it clearly here, which is in your two-way modulator, so the three-way modulating valve. But three-way modulating valve, your total water supply should be constant irrespective of the loads. So that at the AHO level, you will control the amount of water flow. Understood or not?
Yeah.
Am I clear?
Yeah.
Mohammed as well as Vinod.
Yes.
Both of you is clear, right?
Yes.
Yeah, yeah.
Perfect. So like that, we install this. So what we do is we basically create this bypass line. Okay, so this is nothing but a three-way modulating valve. We install it only when we have constant primary pump network, where we install this particular hardware, which is your three-way modulating valve at the outlet of your AHUs or FCs. Clear? Then coming
Yes,
to the
sir.
next hardware is your two-way modulating valve. This two-way modulating valve, you will use it when you have primary and secondary pump or only primary with variable frequency drive. Understand? So first we have to understand the total circuit. Then, I can explain it better. So in this case, you have something called as two-way modulating valve. You have something called as a two-way modulating valve. So it will also have an actuator, temperature setting, everything is same. But only thing is this guy, you'll have both primary and secondary pumps. Okay, you have both primary. So let's delete it. It's not required anymore. So at this location, you have both primary and secondary pumps. You will have secondary this trainers, which is not required. Yeah. So in this case, what we do is when we have both primary and secondary, we will install this two-way modulating valve. I'll just explain it here. This is an actuator, let's say. This hardware we call it as two-way modulating valve. Two-way. Okay. So this two-way modulating valve will install it at these locations, let's say. So this is your two-way modulating valve. This two-way modulating valve, you will install it at these outlets. So what it does is same mechanism. It will have a thermostat, all those things the same. Only thing is it will cut the water flow whenever the room temperature has reached. Understood? Or it partially allows. So basically, you're just manually you are not manually, so automatically you're controlling the water flow that's entering. But you can ask me why it has to. I mean, why we can't do it in the previous case. In the previous case, your pump is basically constant flow. So if you do that, the total water flow, what will happen to the remaining one? Then what will happen? The pressure fluctuations will happen inside the circuit. You agree? If my pumps is only one set of pumps, and let's say it is also a constant flow rate, Can I use this mechanism without bypass just by controlling in that particular AHU? That's your question. Hello.
Sorry.
Yeah, I asked you a question. When you have your, let's say you have got your a constant primary pump, like in like previous days I've explained you, let's say you have only primary pump, which is of a constant speed. Can you just directly switch off the valve or like, can you just directly close the circuit instead of bypassing it? Can I use a two-way modulating valve?
Hmm.
No, you cannot because if you have used it, let's say, I'll just go back to the previous example. Let's take this circuit again, but I don't have any VFD or anything. I just have a primary pumps, let's say. So in this circuit, let's say, if I directly place this two-way modulating valve, I'll just give an example. Let's say each AHU will require some 100 GPM. Okay, I'm just giving some random examples. So this is 100 GPM. This is 100 GPM. Let's say the FCU have got only 50 GPM. Okay, and let's say this one is again 100 GPM. So totally is how much GPM? 350 GPM alwa? 100, 100, 100, and then 50, 350 GPM. So
Yes.
what will happen basically each divided by 2 if you do it. So each pump will have 350 divided by 2. So 350 divided by 2 is how much? 175 GPM. Balance it like this, and then let's say this particular one is a total divided by, because two working ones 10 well, so this I'll write it as 175 GPM. This is 175 GPM, this is 175 GPM, this is 175 GPM. So let's say the circuit is running, I have partially closed it by 50, or I have permanently closed this gate because the room temperature is already set. So if my pump is constant fluid, if it is flowing, then if I suddenly close it, what will happen to this pumps? You're trying to pump 200 GPM, but your pipe circuit, one particular pipe circuit is closed. Then one of the options will happen. One option is the remaining flow, it will go distribute between these three AHUs, and this will cool faster or rapid cooling will happen. Or second thing is if multiple valves are closed at a time, don't you think your pump will fail?
No.
So for that reason, we use this three-way modulating valve where we created a bypass line where the amount of water is always 100 GPM, but how much amount of water flowing through exactly through that particular coil of your FCU will differ or AHU will differ. You agree? Yes or no?
No.
No, if you're unable to follow, please ask me to explain again. I'll explain. Don't worry. So till now, is it clear?
Yes, clear, sir.
But whereas if you consider this one, in this case, you have something called as primary pumps and secondary pumps, and secondary pumps will be able to run with different volumes of water with the use of variable frequency drive. In next lecture, I'll explain you how exactly VFD gonna work internally. So don't worry as of now. So variable frequency drive is a hardware which will regulate the frequency and it can control the flow rate of your pump. Understood? This one is basically a VFD hardware. VFD. So you have VFD for every pump. So every pump you will have something called as a variable frequency drive, and it will be inside your electrical panel anyway. Hydropneumatic system is nowadays you've got VFD mounted pumps. Generally, I try to avoid it because of service issues. But anyway, in chillers anyway. So for all the hardwares, you have this particular one. For all the pumps, you have your VFDs.
Sir,
Understood?
VFD we are using just for controlling the speed rate.
Yes. So when you control the speed, what will happen to the flow rate?
It reducing.
It reduces. Simple. That is
Okay.
what we use it for. So we have something called as secondary with VFD circuit, and along with this, you will draw one more line which you call it as decoupler line. Understand? You will draw one more line which you call it as a decoupler line. Am I clear? So you have something
Yes.
called as a decoupler line that will run between your primary pumps and your secondary pump inlet. Between both the inlets, you basically connect it. So you have something called as decoupler line. Drawing for it. Yes. Make ease and just drawing it. Let's say this is VFD. Between both the inlets, you will draw one more line, which you call it as decoupler line. This particular. So, yeah, let's access to disturbance. But anyway, so here between these two, we will insert one more hardware, which is called as a decoupler line. So this hardware is called as decoupler line. Am I clear? These are in this. So this one we call it as decoupler line. Okay. So this decoupler line will act like a bypass line. I'll just give an example again. Let's again, are you comfortable with the previous numbers? So each one is how much? 100 GPM. You agree?
Yeah.
I mean, I'll explain you later in numericals. How do we get this flow rates? Don't worry, but for now, you consider each one is 100 GPM. So this one is 50 GPM. Being FCU, it has got lesser flow rate. So what is this one? Each pump will be how much? 175, huh?
Yes.
This is 175 GPM. This is 175 GPM. This is 175 GPM. Similarly, this is also 175 GPM, 175 GPM, 175 GPM. So what will happen? You're continuously the water is again. But let's say second AHU and the fourth AHU has got the load is reduced. Let's say, just an example, let's say the second AHU is off. If it is off, do I have to send any water into your AHU?
No.
No. So this is 100% closed. Let's say this is 100% closed. So this particular modulating valve is 100% closed. But whereas in this case, the room temperature is almost equal to set point. Then don't you think you have to allow 50% water at least?
No.
Yes or no?
Yes.
That's saying 50% closed. So if I send this 100% closed and here it's 50% closed, what will happen? The demand of your return will reduce because out this is inlet, let's say this is 100 means here 100 will come out because this is 100% open. Here it will be 0. This guy will be 0 over here because it is closed. Whereas this is again it's 100% open, so it is 50 GPM. And this is again 50 GPM because it is closed by 50%. 100 is inlet, you 50% you have closed, so this becomes 50%. You agree or not?
Yeah.
So then what is the total flow rate at the outlet? 100 plus 50 plus 50. So how much is this? 200 GPM. So this is 200 GPM. You agree or not? Yes or no? So don't you think the total water flow at the outlet of all these AHUs is combination of all the inlet, like together, right? So 100 plus 0 plus 50 plus 100. So don't you think it will, sorry, 50 plus 50. So don't you think your total outlet is 200 GPM, but your inlet is your inlet is your 300 GPM, 375 GPM or not? Sorry, 350 GPM. This is, sorry. You agree till now or not?
Yes.
So for that reason, we have this variable frequency drive and a decoupler line. So here what we do is basically we will have something called as differential pressure transmitter. We have something called as DPT. We have something called as a DPT. It's a differential pressure transmitter that we install at the before the last issue. We'll install this hardware, which we call it as DPT, differential pressure transmitter. From the differential pressure transmitter, automatically, I'll draw it in different color. Let's say, yeah, this is the DPT that we have. So this DPT will measure the pressure difference between two lines, and then it will communicate to the VFD. This game will communicate to the VFDs of the secondary pumps. Am I clear? So, I mean, to all the VFDs, not just single one, but obviously it will be confusing. That's the representation. This is a communication cable. That's it. It's not a pipeline. Okay. So, dotted lines of this. Yeah. So this is the dotted line action. So this is just a communication cable that will go. That's it. Nothing else. So this particular guy, whatever you have it, is nothing but your communication cable that will be connected from your this one. Yes. So this is the dotted line that will be connected from the dotted line represents a cable between your DPT to your VFD. Understood? So now what will happen is whenever the water is flowing, whenever there's a pressure difference, automatically this DPT will basically ask the VFD to reduce the speed. Instead of 50 hertz frequency, it will pump only 45 hertz, or slowly it will reduce the speed. So when it reduces speed, what will happen to the flow rate of your pumps? Your pump is running with lower velocity. What will happen to the discharge and head?
Reducing.
It will reduce. So when this reduces, so automatically instead of 350, then it will, don't you think it will run? No, because instead of 175, it will slowly reduce, say 100, 100, 100. So slowly it will become 300. So what will happen? One side is 300, other is 200. Still you have a pressure difference. So the TPT will still communicate, no, you further reduce. Then it will slowly become 275, let's say. Once it becomes 275, and then again there is a pressure difference. So slowly until it becomes 200 GPM, it will ramp down the frequency. So when it ramps down, then don't you think your flow rate will, slowly your flow rate will reduce? At some point, both will be equal or not?
Yes.
So when it's equal, it will leave that particular flow rate at that constant. So it will leave that frequency like that, so that each will be 200. I mean, two working, one standby Alva. So let's take each one is 100 GPM now. Instead of 175, each one is pumping 100 GPM on both. One is anyway off-road. Very good. Yeah. Yes or no?
Yes.
So it will happen. But you can ask me a question: what about secondary pump? Your primary pumps doesn't have any. Your primary pump doesn't have any flow rate. Sorry, any VFD. So it will still run with 175 into 2. One is off anyway. So 175 into 2. So automatically, each one rotates with 175 GPM. The total flow rate is how much? 350 GPM. But here it's 200 GPM. For that reason, you have your decoupler line. So your pump is pushing 300 GPM, but your secondary pump is it's only pulling 200 GPM. So the balance 175 G, what will happen? 300 minus, 350 minus this one is how much? 350 minus 200 is how much? 150 GPM. You agree? So
Yes.
that 150 GPM will automatically flow in your decoupler line, because you don't have any valve or anything, nothing is required here. Because if this is taking less, it means it's pulling more. So here 300 GPM will reach, 350 GPM will reach till this point. Out of 300 GPM, what is happening here? Only 200 is being pulled by your pumps. Yes or no?
Yeah.
So out of this 300 only is pulled by pumps. Sorry, 200 is only pulled by pumps, and remaining 150 GPM will, it doesn't have any other option except to come through this decoupler line. Understood or not?
Yes.
So water will flow. The balance water between your primary and secondary will automatically flow in your decoupler line, and again it reaches your primary pump. Clear?
Yes, yes.
So here the chiller will get unloaded because it is mixing with cold water directly without heat exchange. So instead of 100% of your chiller load will be 75% or 60% depending again on the water quantity on your decoupler line. Am I clear?
Yes, sir.
Yes.
Okay, so this is nothing but your differential pressure transmitter and your decoupler line. This one is clear. And for this logic to execute, you generally have a PLC, programmable logic control. We use a PLC controller in your secondary power panel. Clear? That is your two-way modulating one, DPT. Of course, this is along with the percentage it's showing, but nowadays you have the DPT, something like this as well. Differential pressure transmitters. It doesn't have any display or anything. DPT. So like this, you have this DPT nowadays. A small hardware that you use it. Understood? It will basically measure the pressure difference. It will automatically, it will have a cable connection. So one is inlet, one is outlet, and you have a cable connection as well. Am I clear?
Same, sir.
So this is actual DPT nowadays that we use it. We don't require display. Why do I want a display? Anyway, I have a display in your panel, right? So this will be connected. Understood or not?
Yes, sir. Yes.
So this is your simple DPT that we installed. Oh, your DPT will be installed always before the last stage actually. Okay, so the total circuit it will be able to observe. So with this, we have completed your DPT as well. This same circuit I'm just explaining using this thing anyway. Yeah. So this is a short note on your valves till now. So we still have few things like your NRV, thermowell, pressure gauge, temperature gauge, and all. Shall we continue in the next class? Is it okay?
Yeah.
Okay, then the next class will continue. That's tomorrow again. We'll continue this class anyway. Not many other, so we'll complete everything. Then I'll explain about your pump theory and how can we select pump selection, pipe sizing first of all, and then we'll go for pump selections. Yeah, shall we wind off now?
Yes.
See you again. Any queries? Please feel free to reach out.
Thank you.